Hello, everyone. It's good to be here in Vegas. My name is Amir Golan, and I'm here with my dear colleague and friend, Mark Rambo.
Hi.
And today we're going to talk to you about configuration management in the cloud. We hope you enjoy the session. To give you a little background of what we're going to be talking about today, so we're going to talk about how configuration management can help you codify your infrastructure. And we're going to talk about some of the benefits of doing just that. We're also going to be talking to you about how you can use configuration management to save time. And saving time by automating manual tasks that you do on a regular basis, like updating packages, setting up application dependencies, or even deploying your applications. We're also going to be talking about some of the best practices on how you can properly set up your applications, your host configuration, set up your infrastructure, and a lot more. So to give a little background on how configuration management came to be and why we're here, I have to start in the pre-cloud days. Back then, infrastructure was mostly static. That means I would have designed my application to withstand a certain amount of load and a predefined amount of users, up to an X amount of users. In today's world, I don't do it like this anymore, but I rather scale my application based on the actual load generated by the actual traffic coming from my users. And the reason I can do that is because I can set up my infrastructure in just minutes, really, really fast. This wasn't the case in the past, but the fact that I can now get infrastructure much, much faster doesn't really mean my job got easier as an engineer. On the contrary, we as engineers are now expected to keep up with that speed of change while still maintaining the same level of consistent results. Now, to put it in other words, we're expected to iterate quickly on our development, our test, our staging, production environments without making any mistakes, which could become a problem if we're dealing with large-scale environments. We all know that fast-moving environments, dynamic environments, require a lot of attention. And this, again, becomes very, very difficult when you have a lot of them. So, how are we supposed to iterate so quickly and operate at such scales? One of the answers to that question is configuration management. So what is configuration management? Well, there's lots of ways to define it, but this is how most of our customers see it. A practice in which code is used to define and maintain the state of both new and existing resources throughout their entire life cycle. Now, I'd like to focus on the last part, throughout their entire life cycle. This means from the time a resource is created until the time it is terminated and everything in between. Like that time I had to log into my server to delete some logs to clear up some space, or that time I had to remove several SSH keys because several users just left the company. To give you some sense of direction of where configuration management actually fits, I'd like to use this following illustration that has compute resources, operating system and host configuration, and application configuration. So, on the compute resource front, I have Amazon EC2 instances. I have servers, even in your own data centers. We have servers in other cloud providers, and even a virtual machine running in your own desktop. So after I provision some compute resources, I probably want to go ahead and do some configurations. I want to create files, directories, define networking settings, symlinks, mount points, registry keys, and the list goes on and on. All so that I can support my application, which even by itself has its own dependencies and its own configuration. But let's assume I've done all of this and I have my application up and running. Does that mean I'm done? Well, not really. Application still requires constant maintenance, ongoing management. I still have to do package updates. I have to deploy new versions of my application. And I even have to mitigate operational problems, like restarting a specific service on my fleet of Amazon EC2 instances. So how am I supposed to get in control of those resources, especially if I have a lot of them? Those of you who have been doing this for a while know part of the answer. You need tools. Tools to help you tackle some of these common challenges, like changing the vhost configuration on every web server across an entire fleet, or installing a new package to test out a newer version, or even tools to change the LDAP configuration on my Amazon Linux instances while not touching my Ubuntu fleet. So, what sort of tools can you use to tackle some of these challenges? In today's session, we're going to be talking about one of those tools, Chef Automate. Those of you who are not familiar with Chef Automate, it's Chef's latest commercial software bundle for doing configuration management and a lot more. So what is Chef Automate? It helps you refer to your infrastructure as code. To be more specific, Ruby code. It also uses a concept of cookbooks that, based on this, you guessed it, contain recipes. And together, those cookbooks and recipes help me codify my host and application configuration. Specifically, those recipes are the real workhorse of Chef. They do most of the heavy lifting. I'm going to use those to install and configure my software components, to manage files, to deploy and scale my application, and even run other recipes. Using those recipes, I'm going to consistently scale my application, whether it's made out of 5 resources or 1,000 resources. I'm also going to use those recipes to maintain a certain state or a policy that you define under a certain instance or a resource. So if I define something in a specific recipe, and someone accidentally logs into an instance and maliciously, potentially even changes something in that configuration of that specific instance, I'm going to use those recipes to revert the state back to its original condition. Revert the change. I'm also going to be using those recipes to save time by automating a lot of the manual tasks I used to do before by hand, by logging into each and every instance in my fleet. To give an example, I could use one recipe to automate a task I do that takes me 5 minutes to do, but I do 100 times a week. If I do just that, I can save off my investment and have that returned to me in the very first week by automating one simple task, that 5-minute task. So how does it really work? Chef uses a simple client-server architecture. When you have your Chef server, right, your Chef Automate server, and you have your instance or server, once that instance identifies itself with the Chef server, it becomes a Chef node. And the life of a Chef node are pretty easy. Just have one task. Ask the server, what am I supposed to do? What sort of recipes do I need to run? It's as simple as that. So in this illustration you see in front of you, we have 2 types of configuration, configuration A and configuration B. Now, configuration A could be representing a web server. That is, the recipes that are assigned to configuration A will eventually make up of a web server if run in a certain order. Configuration B could be representing a different type of web server, or it could even be representing a different tier in the same application. So if configuration A is my web tier, configuration B could be my app tier or my database tier. I'm going to walk you through the steps on how you can set something like this up. So the first thing I need to do is set up my Chef server, right? My Chef Automate server. The next thing I need to do is place some cookbooks and recipes on it and define some roles. Now, I'm going to talk about where you can get some cookbooks and recipes in just a little bit, but once you have those, you can start and associate those with roles. Now, roles define what sort of function or purpose a certain instance or server is supposed to do. And I'm going to use those roles and attach recipes to them. So if I define a web server role and attach 3 different recipes to them, an instance that runs these recipes will eventually become a web server, as you'll see in just a little bit. So once I have my Chef server set up, I'm going to place some cookbooks and recipes on it and define some roles, and I'll attach those roles to those cookbooks and recipes. I'm going to go ahead to step number 2 and install the Chef client on my instance, EC2 instance, or even a server running in my own data center. After that, I'm going to register that instance with the Chef server as a Chef node. And I'm going to assign the node with a role during this process, a web server role, a database role, app server role, and then the Chef client that is installed in the instance or server is going to ask the Chef Automate server for a specific set of recipes or configuration instructions. The server will then determine the applicable recipes based on the specific role that is assigned to that node. And then the Chef client will apply those recipes in a very specific order doing something called a Chef run. During that Chef run, those recipes will be run in a certain order that will eventually make up of a web server giving our example of those 3 recipes. And after that initial chef run, the chef client will pull on the chef server for every subsequent 30 minutes to learn about new configuration changes or new configuration instructions that he needs to run on the fleet. So the chef client executes those recipes every 30 minutes to provide consistent and repeatable results on every single instance or server it runs on. Now, the chef client will only make configuration changes if the node is actually out of spec. That means that what's defined on the recipe is not actually the state of the node. To give you an example, it will only install a particular service on a node if the service is either not available on the node, it currently does not exist on the node, or if it's out of date. That means it's even intelligent enough to understand what changes it specifically needs to do, rather than just running the recipe all over again. To support system integration, Chef supports something called Chef Search. The Chef server harvests information about all the nodes that are connected to him and makes that information available to other nodes through the recipes using Chef Search. To give an example how this might work, imagine we have an HE proxy server that load balances across a fleet of web servers. Now, since we're dealing with dynamic environments, imagine I just scaled up and created 3 new web servers. Now, during the next chef run of that HE proxy server, it's going to ask in its recipe, give me an updated list of all the web servers currently available on the network. And as soon as it discovers about the 3 newly added web servers, it will add them to its configuration and start diverting traffic to them. Another example is imagine we have a database server. Now, that database server serves a fleet of application servers. So imagine at some point, an opposite thing happened. I just terminated or scaled down 2 instances. Doing its chef run, the database server will ask, the chef client installed on the database server will ask, what are the available application servers in my fleet? It will get a response and we'll see 2 of them needs to be removed. So what we will do, it will take their IP addresses and we'll remove them from its access list so that they no longer have read-write permissions to the database server. So to give you some sort of a sense on how these recipes look like, I want to go through this example. So the nice thing about those cookbooks and recipes is that you don't really have to reinvent the wheel. Chef has something called the Chef Supermarket that has a wide variety of community cookbooks and recipe to run virtually any application you're probably already running today. MySQL, Nginx, Postgres, PHP, and a lot more. So let's assume I want to create my very own web server, right? To do that, I probably want to do is install the Apache package and start and enable its service. Probably also want to create and configure my very own custom site. So we're just going to do that using this recipe. As I mentioned before, recipes can also call on other recipes, which happens at the first line of this recipe. We're actually calling the HTTPD service recipe. When we're calling it, we're also passing some sensible defaults that apply to our specific use case. I can pass many of these, like the listen ports, thread limits, timeouts, and more. A very interesting part comes next, the action command, where I'm doing 2 things, create and start. Create handles the package installation, directory setup, and other OS settings. While the start simply starts the HTTPD service on the box. Now notice something very interesting. The create is going to install the Apache package, but it lacks specificity. I'm not telling Chef how really to install it on the box, right? Because if I want to use this on a Debian system, I probably want to use something like apt-get install. Or if I do it on a RHEL or CentOS, I probably do yum install. But this doesn't appear here. And that's the beautiful thing about Chef. Chef abstracts this for you. It knows how to install this regardless of the underlying operating system, which also means you can get cookbooks and recipes that are operating system agnostic, which opens up a whole wide variety of use cases for you. You can now consider a real migration between one operating system to another. So let's move on to the next segment where we're going to create a configuration file. In this segment, we're also calling another recipe, the HTTPD config recipe, that is going to be used to create a configuration file, the mysite.conf.erb. Now, this file is a template file, and it's filled with a lot of placeholder data, right? And it's going to get populated during the chef run. And during that chef run, it's going to look at all the node-specific information I have on that specific instance that it's running on. And it's going to update that configuration file to contain that information. And as soon as that file is created, I have notifies, which will restart the HTTPD service so that it can consume this new configuration file. Now, something very interesting about notifies is that it will be used only if we're actually updating the configuration, only if we really need to restart the service. So imagine at a later stage, during the next chef run, the chef client will actually create another temporary file, a temporary config file from that template, and will compare it with the one already existing on the box. And as soon as it identifies there's a difference, it will replace the old with the new, and will restart again the HTTPD service. The next thing I probably want to do is create a folder where I can place my website. So this is what I'm doing in the first section, where in the next one, I'm also going to create an index.html file, and I'm going to populate that file with some placeholder content. I'm also going to give that file I'm going to assign that file with an owner and give it some read-write permissions. Now let's say I have my site running, but I want to do a little more. I want my website to be able to run PHP code. So to do that, I'm going to have to install the PHP module and enable PHP to interpret PHP files. To do that, I'm doing this call to another recipe, the HTTP module, and passing the PHP file. And that's it. In the next section, let's say I want to take this even forward, and I want to enable my server to have my PHP code be able to talk to MySQL. To do that, I have to install the PHP MySQL package. And just like before, notice I'm saying install. I'm not specifying how to install. Chef already knows how to do this, regardless of the underlying operating system. And once this is installed, the service is restarted once again. Notifies will be called in one of either two scenarios. One, that the package doesn't already exist on the box, right? It's currently not installed, or again, if it's out of date. That policy is going to be used to enforce the state on a specific instance. Chef also has something called Chef Visibility, which, like the name suggests, provide you with a view into the state of your cookbooks, your recipes, the roles you defined, and most importantly, your nodes. And whether what is defined in the recipes actually meets the state of the running nodes. What Chef calls a converged status, and whether your nodes have been converged. This user interface that you see in front of you also serves as a data warehouse platform, when you can use to get insights from your environment. So if I want to verify if a specific package is installed on my instance that contains the server role, web server role, I can do just that by using this user interface and querying for that information. I also mentioned before that Chef is not only a configuration management solution, but it's a lot more. Chef Automate is an automation suite, and it uses tools like Chef Workflow. Chef Workflow is a continuous delivery pipeline of both infrastructure and applications, and you can use it to move a change in your host or application configuration from a developer's desktop all the way up to production. It uses a series of steps where you can begin by verifying the changes to your code locally, have them peer-reviewed and approved by your colleagues, have it run through a build process, have that build run through an acceptance test, for some acceptance tests, go ahead and jump to union, where you can probably have your integration tests, rehearsal, which will represent your staging or pre-prod environment, all the way up to delivered, which releases your artifact to production. All this through the use of those Chef recipes, end-to-end, your host configuration, setting up your application dependencies, and even deploying your applications, all through the use of recipes. This dashboard can also be used, of course, to track the change as it moves through the pipeline. So if you just injected a change, you can track that change as it goes through each and every stage. Chef also has something called Chef Compliance. Chef Compliance lets you generate customizable reports to identify configuration issues, security risks, and even outdated software. And all of those insights that it gathers about your nodes and their compliance state will also be aggregated in the visibility console that you're seeing in front of you. You can write your own compliance rules, or you can quickly get started with Chef's built-in ones. You can also use some of Chef's predefined rule sets that has support for common and existing security frameworks out of the box. So we've talked about what Chef Automate is, and those of you who've been listening to Werner's keynote probably learned that we just released a new service in collaboration with Chef, OpsWorks for Chef Automate. Those of you who are not familiar with OpsWorks, it's an AWS service that gives you a set of operational tools to help you maintain your fleets of instances using automation. And OpsWorks already supported configuration management in the past, which is why we consider OpsWorks to be the place you go to for configuration management on Amazon Web Services. And it is now also the place where you can get your fully managed, single-tenant Chef Automate server. If you might be asking yourself, and you've done this in the past with Chef, how is this different than setting up my own Chef server? Well, that's the point. There's no setting up. You just go to our service console and you can get your own Chef server in just 10 minutes. You just define a name, select one of our supported regions, which are today North Virginia, Oregon, and Dublin, and select the server instance type. We support T2 medium for managing up to 50 nodes, M4 large for managing up to 200 nodes, and M4 2x large for managing 200 nodes and above. The upper number can be thousands depending on the frequency in which your Chef nodes check in with the Chef server. I mentioned it's 30 minutes, but it's something that you can define by yourself. So I also mentioned this is a fully managed service. So to talk about some of the management capabilities you get with this service, we have a weekly maintenance window. This is a 1-hour maintenance window, where during that window, we are doing security updates and Chef version upgrades on your behalf, offloading all the operational maintenance that you had to do to maintain your server. We also support daily and weekly backup schedule that you can set through the service console. These are automatic and will be triggered and happening by our service. These are also non-disruptive, so you can continue working with your Chef server as these backups are happening. The backups are also incremental, so that they are very light in space. Those backups will contain the cookbooks, the recipes, the roles you define, and all the associated node information that was collected by the Chef server. And at any point in time, you can choose to restore from one of those backups. You can even restore to a new copy of your Chef server. That means creating essentially a clone of your Chef server. You can define the rotation of how many backups you'd like to keep, the generations. If you set this to 10, you will keep the 10 most recent backups on your behalf and rotating those backups while deleting the old ones on your behalf. So, what else is left for you to do when using this service? Virtually nothing. This is a fully managed configuration management service. We take care of the backups and the subsequent restores, the updates, the upgrades, so you can focus on writing the best possible cookbooks and recipes so that you can automate as much as you can to keep up with the speed in which your infrastructure changes. Some of the other benefits of using our service. Well, our service also supports automatic instance of Chef server registration. Those of you who have used Chef in the past know of a tool called Knife. Now, this tool will usually be installed in your developer desktop and will be used to register instances, or soon-to-be Chef nodes, with your Chef server. Now, this process of using Knife on your developer desktop uses Knife as a mediator between that soon-to-be node and the Chef server and handles the authentication and registration process. This works very well with static infrastructure, but becomes a little bit of a problem when we're talking about dynamic environments, ones that needs to scale without your developer desktop involvement. And this is why we have registration and deregistration APIs that are coupled with code snippets that we provide you with. You can take those code snippets and insert them into the launch configuration of an auto-scaling group. And once you do, we install the Chef client on every node that is on every instance that is provisioned and do a call to our service to handle the authentication and registration process on your behalf using those APIs. As I mentioned before, this is Chef's commercial product, Chef Automate, but there are no separate license fees to Chef. This is a first-class Amazon Web Services service. That means you only pay as you use. The way this works is you pay a certain fee, an hourly fee, for every node that is connected to your Chef server. So if I connected a node to my Chef server and it's been running for 5 hours and then I stop that node or deregister that node, I will only pay for those 5 hours. It's also an important time to mention that this service has a first 10 node free tier. That means the first 10 nodes that you connect to your Chef servers are free of charge, so you can get started on experimenting with this new service. We worked very closely with Chef on providing you with the best possible way of running Chef Automate on Amazon Web Services. As I mentioned, this is a first-class Amazon Web Services service, so that means you're getting support directly from us. So we provide you with the best possible support and guidance on how to do configuration management on Amazon Web Services. To talk about some of the use cases of how someone would normally use this service, I'd like to mention some of these popular use cases. Chef already exists today, and this is how most of our customers use it. The first use case would be to bootstrap instances into the right state by using those Truth cookbooks and recipes. As I mentioned before, there's a wide variety of community cookbooks and recipes that you can leverage out of the box to install virtually anything: MySQL, Postgres, Nginx, PHP, and a lot more. Another way to use this is to update the configuration of running instances. As I mentioned before, the Chef client will check in with the Chef server for configuration updates every 30 minutes. So if I want to update my web server fleet, I just need to place an updated recipe on the Chef server and wait 30 minutes for the update to propagate to the rest of the instances or registered nodes. You can also use it to assure instances comply with a predefined policy. So if in my organization, I define that a database server is supposed to be run in a certain way, that means supposed to adhere to a certain policy, supposed to have a certain amount of users, supposed to have a certain directory structure, I can define all of this, codify that in the recipes, and have Chef enforce that policy every time a Chef run happens. So even if someone changes that state of the instance, changes the directory structure, or changes anything else that I define in that recipe, Chef will revert the state back. So we've also talked about how this can be used as a part of your continuous integration and continuous delivery pipeline with services or with tools like Chef Workflow. Right? So you could use Chef recipes to trigger an automated build process, integration test, and handle your host configuration and application configuration all through the use of Chef recipes. We also have some tools of our own to do something similar. CoPipeline. CoPipeline is a continuous delivery service that helps you automate your software release process. Imagine that a developer pushes his code to GitHub, and CoPipeline automatically triggers a build process, generating an artifact, having that artifact tested, staged, and deployed to production, all in an automated way, fully visualized. The interesting thing about CoPipeline is that it integrates with tools that you're probably already using today, like Jenkins, RunScope, Solana Labs, and a lot more. And most importantly, it also integrates with the other AWS services. Before we get into it, I'd like to go through some CoPipeline terminology. This is your pipeline, and this is exactly how it would look like in our service console, right? You have stages where we have the source stage, where there we have CoCommit, which is our source control service, our equivalent to Git. We have the build stage, which uses our integrations with Jenkins, which currently runs on EC2 here. And we have deploy. And here you see our deploy service, CodeDeploy. Inside each one of these stages, we have something called an action. And we have many of these, as you'll see in a little bit. And between those, we have transitions. So when the build process is complete, I can move on to the next stage, deploy my artifacts. I can also have parallel actions. In this case, I'm doing a build process using Jenkins that's running on EC2. And in the same time, I also notify my developers using Lambda. And I can, of course, also have sequential actions. I can do the same thing, run a build process, notify my developers using Lambda, and immediately after that, provision 3 instances, place my artifacts on them, and do a test using run scope. And assuming that test was successful, I can promote it to the next stage by doing a transition. We're not going to go through a lab demo with my colleague Rambo.
Okay. So, yeah, Amir told you a lot of things right now. So I would like to get you a bit closer to reality. So, as Amir told you, this is a Chef Automate server, and this actually is an instance that came out of OpsWorks, and that is the service that we recently released in Werner's keynote. So this is the server that I would like to use for the demo. I booted it up because Amir told you it's about 10 minutes to set it up, and we don't want to waste the time here. As you can see, I have that set up quite a while ago, and you see there's a lot of chef runs actually running on those. And there are also a couple of instances connected. One is my Apache demo server, and that's the one that I would like to show you. So imagine you're an entrepreneur, you have a great idea for a new web service or website that you want to build, and the first thing you usually do is you want to claim the ground, and you will maybe release a little sign-up page, something very simple, just to get a name out, maybe pleasing your investors. And before you do that, you just have the web server up and running, and nothing is running on it, and we want to fix that, right? So we want to deploy that really quick, and what we use for that is Chef in that case. And we have a pipeline that we just heard about how that would work. So we use code commit to have our chef recipes, because chef recipes are not other than other code. So it's your configuration in code. So we have that in our Git repository, we version it, and we work with a couple of developers on it. And the next step is then the build process, and we're using that to test and figure out if our cookbooks are actually running nice and if they would converge if we upload them to the Chef server. So in that step, what we do is that we launch an instance running the recipes on it and see if that really works. Because if it doesn't, you don't want to promote that to your live environment, right? Because then you're probably down, and that wouldn't be nice. And the last step is then just uploading it to production so that all the instances can gather the new cookbooks. And as I said, I want to just tell you how we want to just upload something to it. I hope you can see that quite good. If not, I can make it a bit bigger. So I just used a very simple cookbook from the supermarket that Amir told you about, where a lot of recipes are free to use, and they are in the best community standards. And what they define is a couple of attributes that you can just tweak. So the standard installation actually works pretty nice for me. Besides that, I have some little tweaks that I want to do. And one thing is that I want to have my default site enabled because that's the website that I want to have. And let me just fix that. And the other thing that you can see here is the Chef client interval. Usually, the Chef client runs every 30 minutes, maybe every 50 minutes. That's not nice for the demo, so let's run it every minute. So that's a bit overwhelming for the Automate server, but it doesn't matter because we only have one instance. And now, as I said, it's code. So first of all, we need to just gather all the cookbooks together. So I did some changes, and there's a tool called Burks. That is the Berkshire repository tool that gathers all the cookbooks together, all the dependencies, and builds it up. And let me do Burks vendor cookbooks. And that you will see is getting all the cookbooks that I have, put them all together in one folder. And if I do git status, you will see these are my changes. So my Burks file changed because I changed the version of something. I have two modified things in my app cookbooks. That's what I just did. and Works puts them over to the Cookbooks repository. And let me add those git commit. Writing such in the morning. And we push them up to our code commit repository. And the next thing you will see is that the pipeline actually will trigger a run. So code commit has to change. Pipelines will recognize that. And then we're going through all the steps. So it's gathering the source, then it's packaging everything up into an artifact that is then passed to the build step. In the build step, we use that artifact, upload it to the Chef server already, but in a testing environment. So a Chef server has multiple environments, so we upload to test. And then from there, we start an EC2 instance. We connect that instance to our Chef server, run the cookbook from the test environment. You see it's starting. And when the Chef run completes, we are good to go and say, okay, we can promote the cookbooks to the production environment, and then the Apache server will pick that new change up. And if everything works fine, our site will be enabled, and we will see our new sign-up page for the service. But as I said, it's starting an instance. It takes a couple of minutes. Meanwhile, I would like to show you a little bit more about our Chef server product that we released. So this would be the start page of it. I have already 3 servers running, as you can see. And this is the screen that you would end up when you start a new Chef server. So you see that you can download the credentials and a thing that is called Starter Kit. And that actually doesn't let you just start a server very easily. It lets you immediately start getting some cookbooks on it. And what it contains is all the configuration that you need for a Chef server. So let me show you. So this is the knife.rb file that specifies the URL from your server. This is here. We also have self-signed certificate CA. So OpsWorks is giving you a CA so that you can, without having any SSL magic done, directly connect to the server and have a secure connection, which is pretty nice. If you just look up how that is done usually with self-signed certificates, that's not what you want. And you have here the private PEM, that's the client key that we use to authenticate that client. So we have a couple of directories like cookbooks, environments, roles. We have also a box file. And we put in here for getting started easier, one cookbook, that is the Chef client cookbook that configures a Chef client on each node with well standards. So it's log rotated, you have logs in the right place, it sets up that it runs every 30 minutes. All the usual configuration you would do with your Chef client manually, that's all done with that one cookbook that is well maintained by the nice folks at Chef. And we have a README, that's a markdown file, so it doesn't look that nice in my Sublime editor. And that lets you go through a couple of steps and tells you how to quickly build up a Apache server in the cloud, right? And the last thing that I really like to tell you about is the user data. So Amir told you that we have the script that you can just put into your autoscaling configuration or onto CloudFormation or just an usual server. And we have this API that authenticates you against our service. So you don't have to somehow bring the PEM, the client PEM over. You don't have to think about, oh, where do I store it? How can I retrieve it from the nodes? You don't have to use Knife to actually set it up. So we have an API for that, and that lets you integrate very, very nicely with IAM. So everything that you need is the right instance profile for the instance that you want to connect to it. And then you're all set. You just paste that into the user data, and the node will come up and it will be configured. The only thing that you wanted to do is changing the run list here. So the run list is the codebooks that you want to run on the server. So those codebooks need to be already existing on the Chef server, otherwise it will not work, right? But besides that, this is all you need to do to just set up a new node. And just copy paste. That should be something very straightforward for you. And this is how I would do that. So I just put in here the Chef client, because this is what you anyway need on every node. And then you would start an EC2 instance or an autoscaling group or whatever you like. Let's just do that real quick. You go through it, maybe not using a micro one, we are not that cheap today. And you have here in an advanced section the user data snippets that you can just paste in, which is very simple. I'm using this role here. But, well, I should maybe use the other one. Then you just launch it. And it will connect to our Chef server. Takes a while. You can view how it's booting up. And at the end, it will appear on our Automate server. You see there's no connected node so far. If you go to the nodes page, see this one is blank. It only has a couple of recipes on it. And there we will see the client coming up. I hope I actually put the client on it, but that's about it. So meanwhile, let's see how our pipeline goes. Okay, we are in a build step, so that means we are booting up right now the instance that we want to test against, and that should hopefully be quickly done. And what you also can integrate here is more steps to test, right? So infrastructure is really, really critical. If you have a bug in your application, some people might recognize it. If you change something on your application server and it's down, everyone will immediately know it, right? So I would recommend to have everything set up like an integration test that lets you boot an instance, having a test kitchen integrated, which was hard to use with OpsWorks before, but lets you test all the cookbooks. You can have a lot of static checks to see if your cookbooks really work as you expect. And put everything in that makes you confident that your change actually is good for production, right? You can have multiple steps. Okay, it's already succeeding. And if I'm not mistaken, there you go. So you see, congratulations. We just launched, and this is our website. Here you can just go to your new service or whatever you just want to release to the public. And everything looks shiny, and it was just one line of code and a couple of Git commits, and that was it. Let me see if maybe in the meantime our Chef node appeared. Probably not yet there. Okay, but this is about it for the demo. Let's see when it actually appears. And thanks a lot, and I would like to hear any questions, suggestions, and whatever you're up for.
Thank you.